A function f has a local maximum value at a point c within its domain d if f of x is less than or equal to f of c for all x and d lying in some open interval containing c. A function f has a local minimum value at a point c within its domain d if f of x is greater than or equal to f of c for all x and d lying in some open interval containing c. Looking at this function on an inclusive domain of 0 to 3, the absolute maximum value is located at x equals 3, and the absolute minimum value is located at x equals 0. However, there exists a local maximum point c1 at x equals 1, where there is no greater value of f nearby. Also, there exists a local minimum point c2 at x equals 2, where there is no smaller value of f nearby. The next theorem explains why we usually need to investigate only a few values to find a function's extrema. The first derivative theorem for local extreme values. If f has a local maximum or minimum value at an interior point c of its domain, and if f prime is defined at c, then f prime of c equals 0. This theorem says that a function's first derivative is always 0 at an interior point where the function has a local extreme value, and the derivative is defined. If we recall that all the domains we consider are intervals or unions of separate intervals, the only places where a function f can possibly have an extreme value, local or global, are the following. 1. Interior points where f prime equals 0. This can be located visually when the graph changes from positive to negative slope, or vice versa. 2. Interior points where f prime is undefined. This can be located visually when the graph has a maximum or minimum but not a derivative of 0, or a spike in change in slope. We are going to call these first two types of points critical points. 3. Endpoints of the domain of f are another place where extreme values can exist on a function.